Hi, so today we're going to learn about the definition of a radian. We're going to derive the formula to convert degrees to radians and radians to degrees. We use radian measures to find the length of an arc and the area of a circle. So just like we can measure in feet or meters, we can measure angles in different units, degrees or radians. And actually, let me just go back here for a second. Take a circle and say this is the radius here. And if I took this length, and let's say it was like a string or a rubber band, and I could bend it, and I moved it over here. And then I formed an angle from there to there. Again, this radius here is the same length of that, this angle in here would be considered 1 radian. Okay, so 1 radian is defined as the length of the radius going around the arc like that and forming an angle. That's how we define it. All right, so just think about that. If this radius is 1, we know that to go around the entire circle is 360 degrees, right? So if I have this as radians and I went around like this, how many times does this go around? Well, you might remember for circumference, it would be 2 pi r. And if r was 1, it would be 2 pi. So 2 pi radians is equal to 360 degrees. Okay, so let's go over that a little bit more clearly. All right. Okay, so in degrees, 1 revolution around the circle is 360. The formula for the circumference of the circle is 2 pi r. If the radius is 1, then the circumference is 2 pi. So 1 revolution around a circle is 2 pi radians. Okay, so this is called 1 revolution. 2 pi radians is equal to 360 degrees. If you divide both sides by 2, that means pi radians is equal to 180 degrees. Divide both sides by pi and you get radians equals 180 divided by pi degrees. If you want degrees by itself, divide both sides by 180 and you get degrees equals 180 radians. So you want to memorize these formulas here. Anytime I ask you to convert degrees to radians, you're going to multiply by pi over 180. If I ask you to convert from radians to degrees, you're going to multiply by 180 over pi. Let's take an example. Okay, we're going to convert 120 degrees. We're going to convert it to radians. Okay, so what do you want to do here? You want to take the 120 and multiply it by pi over 180. On my calculator, I could do it 120 times pi over 180, and I get a number like this, but we don't usually like to write it that way. We usually like to write it as a fraction. So I'm going to do it this way. I'm going to take 120 divided by 80 and convert it to a fraction. I get 2/3, and then I'm going to multiply that by pi. So I'd like to say that 120 degrees is equal to 2/3 pi. 2/3 pi, okay? If I want to change radians to degrees, now I know this is radians because there's no degree sign, okay? So in order to convert this, I'm going to take my radians and times it by the formula 180 over pi. So you can see that the pi's end up canceling out, okay? And you can just take 180 divided by 12 and you get 15. So this is equal to, and then remember there's a negative in front of here, so this is actually equal to negative 15 degrees. Okay. All right, let's try some more. We're going to convert the degree measures to radians and the radians to degrees. 135 degrees. We want to convert that to radians. We're going to use this formula. We're going to multiply it by by pi over 180. When we want to convert radians, And again, I know this is radians because there's no degree sign. I'm going to multiply it by 180 over pi. For degrees, I'm going to multiply it by pi over 180. And for, oops, I lost it there. This one, I'm going to multiply it by 180 over pi. Now, I want you to pause and try to figure these out. Okay, let's see how you did. So, 135 times pi over 180, you get this number of radians. But I like to write it as a fraction, so I'm going to take 135 divided by 180, and I get 0.75, which is 3/4. So my answer is going to be written as 3 pi over 4. For negative 140 over 360, that's 1/9 equals negative 1/9. And so I know this is going to equal negative 1/9 times pi, or we usually like it to write it like this, negative pi over 9. Pi over 40. Okay, so in my calculator, I could do this. Or I could realize ahead of time the pi's cancel out. So I'm really just doing 5 divided by 4 times 180, and I get 125 degrees. Okay, so these are equivalent. Here, again, notice I knew it was there was no degree sign, so I knew it had to be radians. So I want to take this number, multiply it by 180, and divide it by pi. And I get this number here, negative 358 degrees, which you should notice is really close to 360, right? Negative 360, which means it's one rotation around the circle going counterclockwise, right? And negative 2.28 is about negative 2 pi, right? Which is one revolution around the circle going clockwise, okay? Okay. Here we have, now I want to talk about the length of an arc. An arc is part of a circle. And we could figure out the length of the arc by multiplying the whole circumference of the circle by the central angle. Okay, so let's take this central angle being 90. And I know that the ratio of 90 over 360 is 1/4. So if I know the circumference is 360, then I know that the arc length would have to be 9 feet. Okay, take a moment and look at that. You might want to pause, read it, and see where I got that. All right. How else can I look at this? Well, what if I took 90 and I converted, that's 90 degrees, by the way, there should be a little degree sign in here. 90 degrees, and I converted it to radians. 90 degrees is pi over 2 radians, right? Just using the conversion formula. So if I took my radians and I divided it by the whole circle, which is 2 pi, this improper fraction comes out to 1/4. And of course, 1/4 times 36 is 9. Get your same answer, whether you're going to use degrees or radians. Just remember your ratio. If you're using degrees, it's over 360. If you're using radians, it's over 2 pi. Okay, now I just wanted to illustrate something for you. If I always wanted to use radians, so if this theta represents the measure of the angle in radians, then the ratio of this angle to the entire circle is theta over 2 pi. Then I want to multiply that by the circumference of the circle. Okay, this r can be any value. Notice a little bit of algebra brings me down to that the arc length here, I'll call it S, this arc length here, would equal theta times r. Oops, let's rewrite this, right? Because the 2's cancel out, the pi's cancel out, so the arc would end up being theta times radius. That's kind of an easy way to do it, but remember theta Theta is in radians. Otherwise, this ratio is different. I can think of this also with the area of a circle. So we know the area of a circle is pi r squared, right? So if I wanted to know the area of this sector, I would have to take the ratio of this, the angle in radians, over the whole circle in radians, and then multiply it by the area. But again, notice what happens. The pi cancels out. So you still have this 2 in the denominator, so you have 1/2, that's still there. You have r squared, that's still there. And then you have the theta in radians, again, still in radians, and that would give me the area of this sector. And that's where we're going to go. This is what I want you to memorize. I want you to remember the arc length and the area of a sector. The arc length is equal to the radius times theta when theta is measured in radians, and the area is 1/2 r squared times theta. Again, theta is measured in radians. All right, let's try an example. So let's see what we have here. We have here a softball field, and it forms a sector. Okay, here's my sector. And I want to find the length of the outer fence and the area of the field. So you might notice this is a quarter of a circle. All right. So that's a 90-degree angle. Right. So if I wanted to take the formula for that I just gave you, that the length of the sector is theta times the radius, I can convert the 90 to radians, all right, times it by pi over 180. This is how many radians it is. Times it by 200, and so the fence is about 314 feet long. Now if I want to find the area, oops, sorry. The area, again, that's my angle measure, right? So I'm going to use the formula. The area is 1/2 r squared times the angle measure. So there's my 1/2 r squared angle measure, and it comes out to be 31,415.93 square feet. All right, here's an exit ticket for you. I'd like you to try this and see how you do. All right, pause the video and then I'll give you the answer. All right, I hope you got this. Again, I took my 300, divided by 180, and so in radians, 300 degrees is 5 pi over 3. Then it asked me to name 2 angles that are coterminal, and positive one would be, I could just add 360, and I get a 660-degree angle, would be coterminal. Or for a negative one, 360 minus 30 is 60. Oops, this is a mistake here. So to go this way, this would be a negative 60-degree angle. So negative 60 degree is coterminal with 300. All right, I'm going to give you some assignments that also you're going to do, and I'm going to have a good day. Bye.